Okay, let's take a look at understanding square roots. I think some of you are a little confused about square roots, so I just want to go back a little bit and make sure that you understand what a square root really is. If you think about it, you learned in Algebra 1 that 3 times 3 equals 9, and 5 times 5 equals 25. 10 times 10 equals 100, and A times A equals A squared. So all you did was multiplied a number by itself, and you got something called a perfect square. So these are perfect squares. A radical is just actually, a square root is actually just undoing that process of multiplying a number by itself. Because when I take the square root of 9, I get 3. The square root of 25 gives me 5. The square root of 100 is 10. The square root of A squared is simply A. So all a square root does is undoes that process of multiplying the number by itself. So you're just looking to find a perfect square and then find that number. Now when you're looking at what we call a radical, so let's say I have the square root of 10, this number 10 is called the radicand. The 2, now you'll note that we don't write the 2 in there. In the absence of a number, it's a 2. That's called the index. You won't have to worry about that until you get to Algebra 2. But that's called the index, and this symbol is actually called the radical. So we have just 3 terms to remember. The index, which for our purposes will always be a 2. When you get to Algebra 2, that will change. The radicand, which is the little number that's under the symbol, and then the symbol itself, which is the radical. Now in the process of simplifying radicals, we want to look for a perfect square and a non-perfect square. So if, for example, I have the square root of 50, I can break that down into a perfect square and a non-perfect square. And if you've forgotten your perfect squares, you might want to write those down. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. We probably won't go that high. You'll probably just be using this group up to, for example, 144. Those are your perfect squares. So when you look at 50, you want to ask yourself, what are the factors of 50? 50 can be factored to 25 times 2. Now 25 is on our list as a perfect square. That's what we're looking for. So using our properties of radicals, we can write this as the square root of 25 times the square root of 2. Since 25 is a square root, or a perfect square, when we take the square root, that becomes 5 root 2. So the simplified form of the square root of 50 is 5 square root of 2. Now let's take a look at a couple of practice problems for simplifying radicals. The first one is 96. So you have to ask yourself, well, what numbers can I multiply together to get 96? And I'm not really sure what my perfect squares are. So I'm going to take my calculator, I'm going to take 96, and I'm going to divide by 2. That gives me 48. Well, 48 isn't a perfect square, so I'm going to try again. 96 divided by 3. Well, that gives me 32. 32 isn't a perfect square either. So let's try dividing 96 by 4. 96 divided by 4 gives me 24. I still don't have a perfect square. How about 96 divided by 5? Oh, that's 19.2. That doesn't work. 96 divided by 6. Ah, there it is. 96 divided by 6 gives me 16. 16 is a perfect square. So the factors of 96 are 16 times 6. I can write that as the square root of 16 times the square root of 6. Square root of 16, that's a perfect square, is going to be 4. So I take that out of the radical. The non-perfect part, the square root of 6, remains under the radical. Okay, so that's one method of trying to find those perfect squares. Just take the radicand, which is this number under the radical, and start dividing it by integers until you get a perfect square. So 216 divided by 2, that's 108, not a perfect square. 216 divided by 3, 72, again, not a perfect square. 216 divided by 4, 54, again, not a perfect square. I'm not even going to bother using 5 because I know it's not a multiple of 5. So 216 divided by 6, 36. There I have a perfect square. So I can write the square root of 216 as the square root of 36 times 6. That means I have the square root of 36 times the square root of 6. 36 is a perfect square. This becomes 6 root 6. Okay, next one, 98. Again, I'm going to take 98, I'll divide it by 2, and I get 49. And I recognize 49 is a perfect square, so I can write 98 in its factored form of 49 times 2. I'll rewrite this as the square root of 49 times the square root of 2, so I get 7 square root of 2. So the square root of 98 in its simplest radical form is 7 root 2. 18, I recognize that that is 9 times 2. 9 is a perfect square. The square root of 9 times the square root of 2. Square root of 9 is 3, so that becomes 3 root 2. So that's a little review on simplifying square roots. Oh, I think I have a few more to simplify. I think I have the whole first page of that review packet I gave you. 72, so if I take 72 divided by 2, that becomes the square root of 36 times 2. Square root of 36 times the square root of 2 becomes 6 square root of 2. Now, as soon as I look at 6, I recognize that's a perfect square. The square root of 144 is 12. So some of these you might be able to just put them in your calculator and get that square root symbol. Or get that perfect square, sorry. Get that perfect square. Number 7, 45, I recognize that that is 9 times 5. So I have the square root of 9 times the square root of 5. Square root of 9 is 3, so that becomes 3 root 5. Now 175, when you see that, you know that's a multiple of 25. So you can just divide 175 by 25. So that becomes 25 times 7. So this becomes the square root of 25 times the square root of 7. Square root of 25 is 5 root 7. Number 9, now this one's getting a little trickier. 343. I'm not going to try to divide that by an even number. That wouldn't make sense because I know it ends in an odd number. So I'll take 343 divided by 3. I don't get anything there. 343, I'm not going to bother with 5. It doesn't end in a 5. So I'll go to 7. 343 divided by 7 gives me 49. So I have the factors of 343, would be 49 times 7. I can write that as the square root of 49 times the square root of 7. Square root of 49 is 7, so 7 root 7 is my answer. Number 10, I recognize that 12 can be broken down into a factor of 4 and 3. I have the square root of 4 times the square root of 3, which gives me 2 root 3. Number 10, 10 square root of 96. If I go back, I already had the square root of 96. That's 4 root 6. So that I know I can write as 10 times the square root of 16 times 6. But the tricky part is that I have this 10 out front. So this is 10 times the square root of 16 times the square root of 6. Now 10 times the square root of 16, so that's multiplication. That's a 4. Square root of 6, that gives me 40 square root of 6. Now 245. 245, I'm not going to try to divide that by 2. I'll try to divide it by 5. I get 49 and 5. So this becomes 9 square root of 49 times 5. Again, I have 9 times the square root of 49 times the square root of 5. So 9 times 7 square root of 5, which gives me 63 square root of 5. Hopefully, that's given you enough examples that you will be able to use the process of factoring the radicand into a perfect square and a non-perfect square, and then you will be able to simplify those radicals. Good luck on the worksheet.